It just was such a huge dichotomy, nobody was expecting that at all. Ever wondered what's on the other side of the moon? Picture yourself as a scientist seeing photos of the moon's far side for the first time. Prepare to be surprised. The hidden part looks completely different, covered in countless craters that no one expected. This discovery is not just changing what we know about the moon but also raising new questions. Space used to be a big mystery, but now, thanks to technology like the James Webb telescope, we're exploring it like never before. Come with us on a journey through space where every new discovery opens up a world of possibilities. What is the dark side of the moon? For centuries, humanity has gazed at the moon and marveled at its beauty. Yet, despite all our wonder and exploration, we have only truly explored one side of it. There's a whole other side we rarely see, often called the dark side of the moon. But why is it called that, and why has it stayed so mysterious? It all starts with something called tidal locking. The Earth's gravity has slowed the moon's rotation so much that the same side always faces us. This means the other side, which we can't see from Earth, is the far side of the moon. Sometimes, we can catch glimpses of the far side's edges thanks to a slight light wobble called libration. In total, about 59% of the moon's surface is visible from Earth at different times, but the far side remains mostly hidden. People often think the moon doesn't rotate, but that's not true. If it didn't rotate, we'd see all sides of it as it orbited Earth. In reality, the moon does rotate, but its rotation period matches its orbit around Earth, so it takes about 29.5 Earth days for the moon to complete one rotation and one orbit, making its day and year the same length. The phrase dark side of the moon doesn't mean it's dark as in no light, it means dark as in the unknown. Before we sent spacecraft around the moon, we had never seen this side. Both sides of the moon get almost the same amount of sunlight on average. However, sunlight reflected from Earth, called Earthshine, makes the near side a bit brighter. During lunar eclipses, the far side gets slightly more sunlight because the near side is blocked by Earth's shadow. At night, when the Earth is full as seen from the moon, the near side gets about 10 lux of illumination, similar to a city sidewalk under streetlights, and 34 times more light than a full moon provides on Earth. In contrast, the far side during lunar night gets only about 0.001 lux of starlight. Only when we see a full moon from Earth is the entire far side completely dark. The term dark also applies to communication difficulties. When spacecraft go behind the moon, they lose contact with Earth. This communication blackout happened during the Apollo missions and highlights another reason the far side is considered dark. So, the far side of the moon remains a mysterious and intriguing place, not because it's dark and shadowy, but because it's largely unknown and challenging to explore. With advances in space technology, we're slowly uncovering its secrets, revealing a world that's been hidden from us for so long. The difference between the two sides, the moon's two hemispheres, look completely different. The near side is dotted with large, dark plains called maria, which early astronomers mistakenly thought were seas. On the far side, however, the surface is densely cratered with very few maria. In fact, only 1% of the far side is covered by maria, compared to 31.2% on the near side. Scientists believe this difference is due to a higher concentration of heat-producing elements on the near side, as shown by data from the Lunar Prospector's gamma-ray spectrometer. Other factors like surface elevation and crust thickness also play a role but don't fully explain why the far side's South Pole Aitken Basin, despite its low elevation and thin crust, wasn't as volcanically active as the near side's Oceanus Procellarum. One intriguing theory suggests that the differences between the two hemispheres might be the result of a collision with a smaller moon that formed from the same giant impact that created our moon. This collision could have added a thick layer of material to the far side. However, the far side's chemical composition doesn't fully support this idea. The far side of the moon has more visible craters not because Earth shields it from impacts, but due to differences in lava flows. Lunar lava flows on the near side cover and obscure craters, making them less visible. The National Aeronautics and Space Administration notes that Earth only blocks a tiny portion of the sky from the moon's perspective, so both sides receive similar numbers of impacts. The near side just has fewer visible craters because lava flows have resurfaced it. Recent research suggests that when the moon was forming, heat from the nearby Earth kept the near side warmer for longer. This delayed the solidification of the crust, making it thinner. Meteoroid impacts on the near side could break through this thinner crust and release lava, forming the Maria. On the cooler far side, the crust thickened sooner, making it less likely for impacts to release lava. The far side also has more extreme variations in terrain elevation. The Moon's highest and lowest points and its tallest mountains are all on the far side. Until the late 1950s, we knew very little about this hidden hemisphere. Librations, or small wobbles in the Moon's orbit, gave us occasional glimpses of the far side, but only up to 59% of the total surface and from such a low angle that it was hard to distinguish craters from mountains. One far side feature visible through libration is Mare Orientale, a huge impact basin almost 1,000 kilometers wide. It wasn't even named until 1906, and its true nature was only discovered in the 1960s when images were projected onto a globe. The Soviet probe Luna 3 took the first photographs of the far side on October 7, 1959, revealing a landscape with fewer Maria than expected. These images allowed the creation of the first atlas of the far side, published by the Union of Soviet Socialist Republics Academy of Sciences in 1960. In 1961, the USSR released the first globe featuring far-side lunar features based on Luna 3's images. Another Soviet probe, Zond 3, sent back higher-quality images in 1965, showing chains of craters but still no extensive Maria. The second part of the Atlas of the Far Side of the Moon was published in 1967 based on Zond 3 data and included 4,000 new features. That same year, the first comprehensive map and an updated globe featuring 95% of the lunar surface were released in the Soviet Union. Most of the far side features were named by Soviet scientists, who chose many notable names like Jules Verne and Marie Curie. The International Astronomical Union later accepted many of these names. NASA's Ranger 4 was the first spacecraft to impact the far side on April 26, 1962, but it failed to send back data. The most detailed early survey was by NASA's Lunar Orbiter program from 1966 to 1967, with Lunar Orbiter 5 providing most of the farside coverage. The far side was first seen directly by human eyes during the Apollo 8 mission in December 1968. Astronaut William Anders described it as looking like a heavily used sand pile full of bumps and holes. All 24 astronauts from Apollo missions 8, 10, 11, and 17 saw the far side, and multiple lunar probes have photographed it. Communicating with spacecraft on the far side is challenging because they are out of direct radio contact with Earth. During Apollo missions, this caused tense moments until the craft reappeared. Geologist astronaut Harrison Schmitt lobbied for Apollo 17 to land on the far side, but NASA rejected the idea due to the risks and costs. In 2018, China launched the Qiuqiao Relay satellite to the Earth-Moon L2 point to facilitate communication with the Chang'e 4 lander and Yutu-2 rover on the far side. This point is also considered ideal for a proposed propellant depot for future space missions. China's Chang'e 4 spacecraft made history in January 2019 when it gently touched down on the enigmatic far side of the Moon. This groundbreaking achievement marked humanity's first soft landing on this unexplored lunar territory. Equipped with advanced scientific instruments, including a low-frequency radio spectrograph and geological tools, the mission aimed to unravel mysteries hidden in the Moon's secluded realm. Unlike the familiar near side, which constantly faces Earth, the far side offers a unique sanctuary from terrestrial radio interference, making it an ideal haven for radio astronomy. This advantage allows astronomers to peer deep into the cosmos without the disruptive hum of our planet's signals. In a remarkable development in February 2020, Chinese scientists unveiled high-resolution images captured by the lunar penetrating radar aboard the Yutu-2 rover. These images provided unprecedented insights into lunar ejecta formations, offering a glimpse into the Moon's geological history and internal structure. Such revelations pave the way for a deeper understanding of lunar evolution and planetary dynamics. Building on these successes, the China National Space Administration launched Chang'e 6 in May 2024, marking another milestone with the first-ever lunar sample return mission from the far side's Apollo basin. This ambitious endeavor involved a multifaceted approach, deploying a mini-rover for infrared spectroscopy and achieving robotic rendezvous and docking maneuvers in lunar orbit.